the world stands at the threshold of a technological transformation unlike any before. The artificial intelligence revolution, once confined to the pages of speculative fiction, is now a vivid reality shaping the way industries operate, businesses grow, and individuals create. Everywhere, the demand for AI-powered tools is soaring, from self-driving car manufacturers relying on deep learning, to financial analysts using predictive models, to doctors diagnosing illnesses with advanced image recognition. AI is no longer a buzzword. It's the engine powering the next era of human progress. Across sectors, the impact is both profound and multifaceted. In healthcare, algorithms analyze vast data sets of medical records and imagery, identifying disease patterns and suggesting treatment plans with unprecedented speed and accuracy. In finance, AI automates trading strategies and fraud detection, making split-second decisions that would be impossible for teams of analysts. Retailers harness machine learning to predict trends and personalize the shopping experience for customers across the globe. Even creative industries have been reshaped, with AI-driven tools generating music, designing art, and scripting films. The rapid adoption of AI solutions is redefining not only what's possible, but what's expected. But behind every intelligent assistant, recommendation engine, and predictive model lies a bedrock of powerful computing. To truly leverage the potential of AI, whether you're a data scientist, software developer, or entrepreneur, you need more than just sophisticated algorithms. You need hardware built to meet the demands of modern AI. And at the heart of that is the AI workstation. At first glance, an AI workstation may seem much like any powerful desktop computer, but a closer examination reveals a system purpose-built for the unique rigors of machine learning and deep data analysis. At its core, an AI workstation harmonizes a range of essential components, each playing a vital role in enabling advanced capabilities. Let's demystify these key elements. First comes the processor, the CPU, or Central Processing Unit. In traditional computing tasks, the CPU has long been king, handling instructions that span everything from running your operating system to executing spreadsheets and web browsers. But for AI workloads, especially those driven by neural networks and complex computations, the CPU can quickly reach its limits. Enter the GPU, or Graphics Processing Unit. Originally designed to manage the intensive computations required for rendering graphics and images, GPUs have architecture that makes them exceptionally well-suited to AI. Unlike CPUs, which typically contain a handful of cores optimized for high-speed serial processing, GPUs feature thousands of smaller cores perfect for handling parallel tasks. This means they can simultaneously process the massive volumes of data inherent in machine learning, unleashing unparalleled speed gains. Alongside the processor and GPU, memory is a crucial factor. AI workloads demand access to vast data sets, making high-capacity, high-speed RAM vital to prevent bottlenecks. Storage, too, is essential. Solid-state drives, especially those using NVMe technology, deliver the fast data access needed to continue feeding hungry algorithms. Finally, these components require robust cooling and reliable power delivery to maintain peak performance during demanding tasks. Yet, it is the GPU that stands as the crown jewel of AI workstations. The power of graphical processing units lies in their ability to handle intensive mathematical operations at scale, a necessity in the age of machine learning, where models are trained on millions or even billions of examples. Every iteration, every training epoch, demands vast computational muscle, and it's here that the GPU truly shines. To appreciate the pivotal role of GPUs in AI, it's important to understand the workloads AI imposes. Take, for instance, deep neural networks, the backbone of technologies like facial recognition, natural language processing, and autonomous vehicle navigation. These networks consist of layers upon layers of interconnected nodes, each one performing calculations on huge matrices of data. Training them requires iterative adjustments of parameters, involving billions of mathematical operations. A traditional CPU, with its limited number of cores, can process these data sequences efficiently only up to a certain scale. As models grow in complexity and the datasets balloon in size, performance slows dramatically. In contrast, a modern GPU, such as those from NVIDIA's RTX or A100 lines, boasts thousands of cores working in tandem. This parallelization turns days of computation into hours and hours into minutes. The performance difference is not theoretical, it's visible in every domain where AI is put to work. Imagine a medical laboratory training a deep learning system to identify tumors in MRI scans. With a CPU-only setup, processing tens of thousands of high-resolution images would take days or even weeks, stalling research and delaying critical results. By deploying a GPU-based AI workstation, the same workloads can be completed within hours, empowering scientists to iterate more rapidly and physicians to offer faster diagnoses. In the realm of autonomous vehicles, the speed advantage is even more vital. A self-driving car ingests camera feeds, radar scans, and LiDAR sensors every second, interpreting its environment and making split-second decisions. During development, the training of these multimodal networks must happen at scale, often in real time. GPU acceleration allows car manufacturers to continually refine their models, improving safety and responsiveness before vehicles ever hit the road. Even content creation is transformed. Graphic artists and video editors are leveraging AI-driven effects and upscaling tasks that previously took hours to render with CPUs. With high-powered GPUs, real-time previews are possible, unlocking creativity and efficiency. Game developers use AI-infused models for animation, voice synthesis, and procedural world generation, all accelerated by GPUs within their workstations. In research, the impact is equally dramatic. Scientists are now able to tackle previously intractable problems, from modeling climate change to simulating the folding of proteins. These complex simulations depend on processing gargantuan datasets, iterating through countless variables, and undertaking well beyond the reach of CPUs alone. With GPUs at their disposal, researchers compress years of analysis into a fraction of the time, accelerating discovery and innovation. The numbers highlight these advantages starkly. Benchmarks reveal that GPU-equipped systems can outperform CPU-only counterparts by orders of magnitude when training deep learning models. In some convolutional neural networks, GPUs accelerate training by over 50 times compared to CPUs. That's not just faster, it's transformative for what can be accomplished in the span of a day or across the timeline of a project. But perhaps the most significant aspect of AI workstations is their accessibility. What was once the domain of giant supercomputers is now available in compact systems that can sit beneath a desk or beside a monitor. Whether you are a solo practitioner experimenting with AI models, a small business integrating automation, or a large enterprise powering global analytics, AI workstations put unprecedented computational power within reach. As AI technologies become ever more ingrained in daily operations, the case for AI workstations only strengthens. They enable smarter automation, foster creativity, and drive competitive advantage. With their balanced combination of high-performance CPUs, abundant memory, rapid storage, and, most critically, powerful GPUs, these machines are the cornerstone upon which the next generation of intelligent systems will be built. Yet, the benefits are not limited to technical professionals. Developers enjoy seamless training and deployment of complex models, while business leaders benefit from faster insights and more effective strategies. For educators, AI workstations serve as valuable teaching tools, allowing students to experiment hands-on with state-of-the-art machine learning. For innovators and startups, they provide scalable tools to move from concept to market, accelerating the journey from idea to impact. In short, the rise of AI workstations signals the dawn of a new era. No longer must artificial intelligence be the preserve of academia or multi-billion-dollar corporations. The tools for meaningful AI development are more accessible than ever, unlocking potential across every field of human endeavor. Whether your ambition is to revolutionize healthcare, automate business operations, or push the boundaries of creative expression, a powerful AI workstation is the key that turns vision into reality. The revolution is here, and it's being driven not just by brilliant algorithms, but by the extraordinary machines designed to bring them to life. Embracing the future means equipping yourself with the tools to shape it. The AI workstation is more than a piece of hardware. It is your window into the future of innovation, a future that is being built, trained, and powered every moment by those ready to seize its potential. Thanks for sticking around. Don't forget to subscribe us. See you tomorrow.